All right, well, hello everyone, and thanks for coming along to the session. My name's Steve Roberts. Your co-pilot today is Norm Johansson.
Hi, everybody.
If you were at the .NET talk yesterday, you'll know that Norm and I are software developers at AWS. If you were not at the talk, Norm and I are software developers at AWS. We work in the team responsible for the .NET SDK for AWS, the Visual Studio Toolkit, and more importantly for today's presentation, the tools for Windows PowerShell. So in the session, we're going to take a look at how can we move a physical server into the cloud. Now, a little bit of smoke and mirrors here. We don't actually have a physical server here, right? And we don't have a corporate network to connect to, right? So we're going to do a little bit of simulation. But basically, we're going to go through how can we virtualize a server or take existing VMs and move them into the cloud, right? You may have VMs running in your organization today that are now beginning to stress the hardware they're actually physically running on, right? And you want to take advantage of perhaps the bigger EC2 instance types to get them running in that. Once we get the server imported into EC2, we're going to take a look at how can we connect the private network, how can we launch it into a private network and connect it back to our corporate on-prem network, how to do it securely, just in case this server has things on it that you don't want on the public internet. And then we're going to set up monitoring of the virtualized server, right? Once it's under our desk, we can keep an easy eye on it. We know when things are going wrong, we hope, right? Once it's in the cloud, we don't have that physical access. So we're going to show how to set up monitoring, and we can keep an eye on it from a distance. Our focus is going to be on repeatable, scriptable automation. No button clicks, okay? Now, why automate? Today, it's just one server that we're going to move, right? In a month's time, 6 months' time, it could be tens of servers, hundreds of servers, right, if you have a fleet of VMs. If I ask Norm to repeat the steps in a week's time, there's a good chance he'll remember what we did, and he'll get it right. A month's time? Yeah, reasonable. 6 months? Unlikely. 12 months? Forget it, right? Because some new core CLR thing will have come out and he'll be distracted, right? So we're going to capture what we do in a script that we can automate, right? We're looking for consistency. We want to make sure that when we run these scripts or when we do these operations, we get the same results every time. Now, once we do that, and we put it into, say, version control, right, we have a safety net, right? If we need to move another fleet of servers at some point down the line in time, but we need to make slightly different changes how it's done, we can easily clone the script to make the changes we need and run it again. And we're going to get predictable results, right? If we make a mistake, and we do something wrong, and it all bursts into flame, and we're all running around with our hair on fire, instead of trying to resort to a wiki that is probably now out of date, right, with what we did last time, we can just roll back the script, rerun it, we're back to a known good system. And obviously, when we're talking at cloud scale, right, button clicks don't scale. Norm only has one mouse that he can click, right? Well, we can do 2 mouses off. But it just generally doesn't scale, right? We want the scripts, they scale easily, right? We can just run those in an automated fashion just over and over and over and over again for however many instances that we need. So that's why we're so insistent on automation. We don't want any button clicks. So in the session, we're going to take a look primarily at the AWS tools for Windows PowerShell. So this PowerShell module now numbers in excess of 1,300 commandlets as of this morning's release. We sim ship. Every time the .NET SDK updates, the PowerShell tools update automatically. They use the .NET SDK underneath. We're then going to use Amazon S3 and Amazon EC2 together to actually import our server. We're going to be using the new import service that EC2 launched, I believe, earlier this year, was when I blogged about it. We're then going to create and configure the private network with Virtual Private Cloud. And we're going to use Amazon's Simple Systems, EC2 Simple Systems Manager to actually do some post-launch configuration. We're going to want to do things like domain join. We want to set up the monitoring. So before we progress into the scenario, I'd like you to meet Norm, our developer.
You really left that picture in there.
Yeah, I did. Norm has a problem, well, one, a problem scenario that we want to go through today, just to sort of set the talk up. So Norm, why don't you tell him what your problem is?
Well, one of my problems, one is working with you apparently, because you do things like this, is my boss came over to me and said that one of the other devs who just left was running one of his production systems under his desk. And of course, he didn't leave very much documentation. And now that box is not starting to work very well. And he said, my job is now to fix this system up.
Okay, I'm kind of scared to see if anybody's actually been in this scenario. I know I have, right? And it's pretty scary, right? So Norm, you've obviously gone through your options. What do you think?
Well, a few things I could do. I could try and actually log onto this box and figure out what's wrong with it. But I don't have any clue what's on this machine, and quite likely I will make problems worse. I could try and buy a new box, provision it, but since I don't know what's on the other box, the likelihood of actually getting everything correctly configured on the other box is pretty slim. So what I thought I'd do is I know there's a lot of third-party tools we can use that actually will capture this physical machine into a virtual machine, and then I would like to host that up into a cloud.
Okay. Let's see how. So what we've done is put together a PowerShell module, and we've pushed it onto GitHub along with the samples from yesterday's .NET session that you can use to actually automate this process. You can use to get started. It includes a number of commandlets that and functions we're going to run through today. This is a level 200 session, so we're not going to go too deep into the script code, but it should give you an idea of how you can get started and how you can adapt this and extend it for what you need. It does include a single command that runs the entire process end to end, if you find that useful. But we're going to focus on the individual commands so you can see what's going on and get a feel for the steps involved. Please take the code, modify it to your needs, and if you're on GitHub right now, pull the module down and follow along. So the process steps we're going to go through. First, we're going to do some tool setup. We're going to get the tools for Windows PowerShell installed. Well, they're already installed, but set up and ready to go. And then the actual import and launch is 4 steps. Import and convert, create the network, launch the server, do the post-launch configuration. So let's get started with the tool setup. So I mentioned that the tools are already installed on the machine that Norm's using. If you're using EC2 Windows images, the public images, the tools for Windows PowerShell are already pre-installed, and they revise every time EC2 revises the Windows images. If you're working on your local workstation, you have 2 options. Traditionally, we've distributed the tools in a Windows installer, along with the SDK for .NET and the Visual Studio Toolkit. So a lot of users still use that. If you're using Windows 10, or you have the Windows Management Framework 5 preview from back in April of this year, I believe, and there was a refresh about a month or 2 ago. If you have that installed, you can use the new PowerShell Gallery. Now, when you use the Gallery, installing the PowerShell module is as simple as typing install-module name address PowerShell. And that will install it for all users on the machine, so it will prompt for elevation. Okay? If you add a scope parameter to that with current user as the value, you can install it on a per-user basis. And this has some advantages because it will keep the historical versions of the module installed as well. So if you need to roll back at any time, you have the capability. With the Windows installer, we overlay what was already on the machine. So that may be of interest to you. So let's go through how you would get started, your first 5 minutes with the tools. So here we are in the ISC. And Norm, when we make calls to AWS, obviously we need credentials.
Right. Okay?
And most AWS resources are scoped by region, so we need to set up a region. Now, all of the commandlets take access key and secret key parameters and a region parameter. Right? It gets pretty tedious typing in a secret key over and over.
I love doing it.
And we also don't want to put any of those keys in our scripts, right? So what we'd like to do is be able to use the SDK's credential store, which is shared with the toolkit for Visual Studio and the PowerShell tools. And the way we do that is using the commandlet called set-AWS credentials.
Okay, so set AWS credentials.
And we'll type in our access key and secret key from wherever we got them.
The secret.
Now, if we were to hit enter at this point, those credentials will become live in this shell, okay? But when we close the shell down, you'd have to type them all in again in another shell, right? We want to store them. So the way you do that is to use the store as parameter, and you give it a profile name. And this is the name you will use to reference this set of credentials in future. It's very much like using the toolkit and the SDK.
Okay, I'll call it live demo.
Okay, so hit enter. So those credentials are now in the store. In fact, we can see what we've got on the machine. If we type get-AWS credentials, and there's a switch parameter called list profiles, you can see we've got 2 profiles set up now. The live demo that Norm just set up, which won't obviously work, they weren't real keys, and the ones we're actually going to use. So that takes care of setting up credentials. In our scripts now, or in our shell, all we would need to do is just type, to activate those credentials, we go back to set AWS credentials, and we give it the profile name that we want to use. And within your script, you can switch around credentials at will. These will get stored in a variable. In fact, you can see here that it says live demo at. I have a customized prompt in my PowerShell ISC and my shells that shows me the region I'm in and the credential set I'm using. So I always know where I am. So that's credentials. Let's switch to a real set of credentials because we're going to want to make some calls in a little while. So let's use the reinvent 2015 set. Okay, so now we want to set up a region. Now, all the commandlets, again, will take a region parameter, but it gets a little bit tedious. So I always have a default region set up. And the one we're going to use today is US West 2. Okay? So you do that with set default AWS region, and then just US West 2. And within your script, you can change these around. If you need to run a commandlet against a different region that you're currently using, you've got set default in your shell, just add the region parameter, and that will override the shell default. Okay? So now we have credentials set up, we have a region set up, we're good to start calling AWS, right? But there are over 1,300 commandlets covering the vast majority of the AWS services, right? So finding a way around can be a little bit tricky when you first get started. So what we do is we effectively namespace the commandlets by adding a little 2 or 3-letter prefix to the noun. Okay, so S3 is an obvious one, EC2 is another. You can find out what mnemonics or the prefixes in use are by using our version commandlet. So you type get-AWS PowerShell version, and if you add the list service versions, list service version info, yeah, you'll see that in the center are the mnemonics that we apply to the noun. Okay? So now you can do things like get command, -noun, S3 star, and see all the S3 commands. It also tells you exactly which services are supported from PowerShell. Okay? So that's how to find out what services are there and what the mnemonic is. Sometimes, though, you might be familiar with the actual service API, right? And you want to know, PowerShell has a slightly restrictive verb and noun naming scheme. What does that map to in PowerShell? So we have another commandlet that will help with that. And that's called get-AWS commandlet name. And you give in the API operation. So let's pick one now.
Well, we're going to run instances, so let's run instance, right? Run instance, yeah.
And that will show you that the commandlet is new EC2 instance. Okay. Now you can use regex queries in this to match with regex switch. So if you're unsure, you can just type in just enough that you think you recognize, and it'll come back with all the matches it has. It also has another little cool feature. When you look through our documentation, you'll see a lot of samples for the AWS CLI. It can translate to some rudimentary form an AWS CLI command into the equivalent PowerShell commandlet name. Right? So this is useful if you find a sample and you want to know what would it be in PowerShell. So to do that, you execute the same commandlet, and this time you give it the AWS CLI command, and you just need to give it just enough that it can parse it.
So AWS EC2, and what is the?
It would be run-instance is in the CLI.
Okay.
Okay. That should come back and say new EC2 instance. Okay. You don't need the AWS prefix. All it really wants is it's looking for the service code and then the name. Any parameters, it'll just dump. It's not actually going to translate the parameters for you. But that's the way you can get started in finding a way around the commandlets and figuring out, what's the PowerShell for this. Okay, so let's head back to the slides. That's us started. We're set up. We're ready to go. Let's start importing our server. Now, as I said earlier on, we don't actually have a physical server under the desk that we're going to import. So we already have a VHD, a virtual machine image that we're going to use today. But if you're actually going to do this on a physical server, there's some tools you can use. This is no particular endorsement. These are just some that we just quickly Googled for. SysInternals has a free disk to VHD tool you can use. They're generally called P2V migration tools. You can find some in System Centers. There's a very long link there, but the slides will be available. There's also a link there to the EC2 import prerequisites. It lists things like licensing info, what kind of versions you can import, etc. I encourage you to go and read that there. So to actually do the import, it's actually a very simple 3-step process, as far as you're concerned. You virtualize the hardware, or you take your existing VM so that you have a virtual machine image file. You then upload that file to S3. Once the file's in S3, we need to set up a role and role permissions so that EC2 can access those artifacts. Even though this is within AWS and it's their services, EC2 does not have permissions to access your S3 artifacts unless you give it permission. Okay? So the first thing we're going to do is set up a role. We're then going to add an assume role policy to that role so that EC2 can get credentials on your behalf to do work. Right? You probably all used this sort of stuff before. Once it has those credentials, though, it still can't do anything. We're going to attach a role policy that's going to give access to the specific artifacts in S3 that we're going to import. Once that's set up, we then make a call to EC2's import routine saying, hey, here are my artifacts. Please do the import and convert. And then we just sit back and wait. And the ultimate result of that will be a private Amazon machine image that you can then go and launch as an EC2 instance. Sound good enough? Sounds good. Let's go do it. All right. So I mentioned earlier that we've written a script module that codifies all of this. We've got the actual script module here. The script's loaded. So let's import the module. Okay. Import.
Okay, and it's...
There we go.
Okay.
Okay, so you can see we've got 5 tabs open. The first tab is the do it all for me script that we wrote. Okay, so this will do the import. It'll wait for the import to finish, which can be tens of minutes, an hour, whatever the size of the image is. And then we'll actually go off and launch, create the network, launch, etc., with just a few parameters. We're not going to use this one. We're going to go through the individual commands. So let's go to the second tab. And this is the import routine that we're going to step through. So because we want to step through the code, and we're not going to do it to any great depth, we're going to step through it. Let's set a breakpoint in here so that we can do that. So PowerShell has a breakpoint command, set PS breakpoint, but it has a very helpful alias, SBP, to save you typing all that now.
Okay, I don't want to type all that.
Right, so you give it dash command, and then you give it the function name that you're going to run. In this case, it's going to be import dash VM to AWS. Okay, our breakpoint is set. So let's start running it.
All
so
right.
We're going to import VM to AWS.
So.
Now the first parameter, resource group name, you'll see this consistently through all the functions that we wrote for this. When you're building a collection of resources that you're going to use together, it's helpful to tag them all in some common way so you can identify them all later on, or use a consistent name scheme, right? That's what this resource group name is. We're going to use this consistently throughout this to identify this collected set of resources, if you like. So let's give this a tag of reinvent.
Okay.
Okay. The second parameter that we're going to want is the VM file. What do you want me to import and convert? Okay.
Okay, I think you put that under reinvent, is that right?
Yeah, it's under reinvent 2015, VM, and it's cunningly named under disk server.
Very cunning.
And then the third and final parameter is the bucket name. Where in S3 do you want me to put this? Right? It's your bucket, you have to tell us where it's going to go. Now, bucket names are globally unique, so I grabbed the name under desk corp.
Under desk. Any hyphens or anything?
Nope.
Okay.
Now, we could add a verbose switch here to see the output, but as we're going to step through it, we'll just skip that. Let's just hit enter and execute.
Okay.
So, Norm, you're a PowerShell newbie, relatively.
Relatively good.
Let's see if you can describe what's going on.
All right, so it looks like we're going to first just validate that we've had the default region, because we didn't want to specify the region individually for all the commands. Make sure our VM file actually exists and that our bucket actually exists. And then we're going to take care of uploading that to S3. So in here we're going to create that S3 object key, and then we're using that resource group name that you use as a prefix of it. That's sort of how we can group things and tag things in S3. And then looks like you're getting the object. Is that what's going on here?
Yeah, so what we're actually doing here is getting the object metadata. We're looking to see, does this object already exist in S3, right? The image that we're attempting to import here is 22 gig in size. Right? Now, on the corporate LAN back in Seattle, it takes about 4 minutes to upload that. Over my home Wi-Fi, it took 2 days. Right? So we didn't want to stand here and wait while it did the import. We've already uploaded it, right? So what this is doing is going, if the object exists, get me its metadata and look at its length and when it was written, and compare that to the local file. Right? If you haven't changed it, don't upload it again. So that's all that's doing. If it did need to upload it, you see down below, it's going to use the write S3 object. So get S3 object gets the object metadata, not the content. To get the content, you use read S3 object, and corresponding write S3 object to upload. And under the covers, that's using the SDK's transfer manager, so it'll upload in a multi-threaded, push the content up faster.
So now it looks like we need to actually give EC2 permission to access S3.
Yep.
So for a second, I'm going to assume role policy. Is that what's going on?
So this is the assume role policy. You'll find this in the EC2 import documentation. It's just cribbed directly here because certain fields need to stay the same, like the service name, etc. So that's our assume role policy. That's going to allow EC2 to get credentials, temporary credentials, on our behalf to do work. Not necessarily call anything yet, though.
So this gives me basically EC2 can call the assume role API call, get credentials, but it still can't do anything, right? It
Correct.
just gets credentials. Correct. Okay. So then we're going to go and see if that role exists. It doesn't, so create it. And so here's the policy where we're actually going to give off those permissions.
Right. So you can see we've got a couple of operations in there that EC2 wants to call against S3 to get the content. Okay.
And then it looks like you're locking down the resource to the actual S3 object key. So we're only going to give access to EC2 to just this object.
Yeah, so this could be a one-time operation, right? If you're doing multiple imports, you might want to put them all in the same bucket under a similar key prefix, and then you would just do this once, right? To show that we can lock down to the specific artifact, we chose to make a more restrictive policy today. And then EC2 underneath that needs a few operations it's going to run as well. EC2 can't call itself unless you give it permission. It was pretty cool.
Yeah.
So we set that policy up.
So there's just the PowerShell commands that actually write that IAM policy.
Yeah. So we're using splatting here. Some of you may not be familiar with splatting. Some of the commands can run off the edge of the screen, especially on these small resolutions. So we collect the parameters into a hash map, a hash table, and then we just give that to the PowerShell commandlet. PowerShell does all the binding for us. It's pretty convenient. So there's a pause in here now, right? We've just called Identity Access Management's global endpoint in IAD, US East 1. So now that's been propagated out to all the regions. It only takes a second or so. In fact, it's done now, right? This is just there in case you run this at full speed. So we return the role name because we're going to use that.
Okay.
So now we're on to that third stage, right? We've set up our artifacts, we've set up our role. We can ask EC2 to go and do the import. Okay,
so this is setting up that image disk container. Looks like the file extension is what we're using to determine the format.
Yeah, so we support VHD, OVA formats, and I believe VMDK, I think is the other format that we support right now.
Okay, and then looks like we're just telling it where our actual image is in S3.
Yeah, there are a couple of other ways you can also identify where the artifacts are. We've just chosen to list the bucket and key here.
Okay, after that we are just calling the import command.
And you'll notice we're passing the role name so that EC2 knows what role to use to do the work. And that's it.
That's it.
Right? So what we've been returned is an import task, a conversion task. If we scroll up through here, you can see there's the task that was returned. And you'll see that there's an import task ID. So this task is effectively asynchronous, right? It's going to go off and it's going to take a while to do its job, right, to do the conversion. It's not available immediately. So we can go and test. We can, every so often poll, are you done yet? Are you done yet? Which is what the main script, the end-to-end script does, right? Just to be aware, they will just sit there and wait. Then it'll go to sleep for a minute and then it'll test again. At any given time, we can check the progress by using the get EC2 import image task, I believe it's called.
Okay.
Yeah.
If your PowerShell session is closed, the import is still happening.
Oh, yes. Yeah. Yeah, it's happening in the cloud now. We're done. Yeah. And you just give it the import task ID. Still pending. Okay, we'll come back and check out.
So when this is done, obviously, status will change to completed, and we'll actually have an image ID, which is the Amazon machine image.
Yes.
That we can then go launch.
And if you look at the end-to-end script that we have, once the import and conversion is complete, we actually take the image ID out of that, and then we go and apply the tag, the resource group name tag to it automatically. Okay? So back to the slides. So Norm, what do you learn as a PowerShell newbie?
I learned now in PowerShell how to actually upload our image to S3. And then we needed to give EC2 access to actually access the object in S3. So we learned how to set up those IAM roles and the permissions and how to be able to assume the roles and get those credentials. And then after that, we set up how to start the import conversion. We called that PowerShell commandlet, which gave us our import task ID that we will then just continually to poll to see when the actual completion is done.
Right. Step one done. Just three to go. We're going to create a network now. So the server that we've uploaded, we're going to assume it has some critical system on it, some HR system that, we don't want on the public internet. So we're going to launch it into a private network using a virtual private cloud. So VPCs let you subset an AWS cloud into a small private region, your own IP addresses. You can configure inbound and outbound access with network access control lists, security groups, etc. You have a tremendous amount of control over the VPC topology. And you can bridge it securely with your on-site network, so effectively extending your corporate network out into the cloud. There are a couple of white papers listed on here that I'd encourage you to read if you haven't seen them. Now, VPC is a very deep and very powerful topic. We don't have time to go into it in a huge amount of depth today. Again, it's a level 200 session. So if you read those, what we're going to do is walk through how we would potentially set up our VPC, and then we'll see what we've actually done to simulate that. So there's our lonely corporate data center that we want to bridge to. Now, like a lot of AWS things, everything starts with a region. VPCs are scoped by a region. So the first thing we're going to do is create a VPC. And we're going to give an address range, in this case, 10.0.0/16. So 10.0 is the significant parts of the address. The rest will match as far as rating is concerned. Regions obviously span availability zones, right? That's how we do our fault tolerance, etc. VPCs also span those availability zones, and they do it by creating things called subnets. And subnets do a number of jobs for us. Firstly, they anchor parts of the VPC to an availability zone, and you can create multiple subnets in an AZ, or just one, or none. It's your choice. You have that complete control. The subnet also partitions the address space down. So you'll notice that in subnet 1 here, we're using 10.0.0/24, right? So we've cut it down to just 200 and some odd servers. Subnet 2 is using 10.0.1.0.24, all right? Inside the subnets, that's where we run our instances. And every VPC comes with a router. Hey, I said it right, cool. As a Brit, that's really hard. You'll notice that we have a route table at the bottom here, the main route table, the default route table. All subnets are associated with that route table by default, right? Unless you explicitly override and set a custom route table. And that just basically means all traffic is local. Nothing's coming in, nothing's going out. Not quite what we need. We want actually hooked to the corporate data center. And there's a couple options for that. We could use Direct Connect. What we could also use is a virtual private gateway. So here we'd attach a virtual private gateway to the VPC. We'd have a customer gateway on site, which is software or hardware, and a VPN connection linking the two. And then in this particular example, we've applied a custom route table to only one subnet. So any traffic that's not for the local VPC is going to go out through the gateway to the corporate net. Right? Now, what this allows you to do is if you do want to have public internet access, say for subnet 1, you can still route it through all your internal proxies and filters, etc., to control that access. Alternatively, you could just attach an internet gateway to the VPC and then control the routing there. Okay? And this is very similar to what we actually want to do today for our demo, right? Except that we don't have a real domain. So what it did, I set up a VPC that simulates the corporate network. And that's on the left side of the screen. Okay? So that's running a VPC. It's got a couple of subnets in it, for example. It's running a simple AD with the AWS directory service. It's simulating our domain. On the right-hand side is the VPC that we're going to set up to host the server that we're importing. So that's going to have, again, a couple of subnets in a 172 address range. When you use VPC peering, as you see in the center here, the address ranges shouldn't overlap. It's got a router by default, etc. And then we're just going to set up VPC peering between the two. And we're going to do all that from PowerShell. So let's do it.
All right. So this is, I'm assuming, this create VPC network script we're going to do?
Yep. So let's set a breakpoint.
SVP command new VPC. Okay. So resource group name, that's going to be reinvent
again. It's going to be reinvent, yeah. Okay. So then we want the base address for the VPC that we're creating. So that's the 172.0.0.0, okay? And what will happen is the script will actually partition that down into subnets automatically for us. Then we want the name of the VPC that we're going to peer to. This is our corporate simulation network, okay? Now, a general practice that I've found quite useful is instead of expecting operators to type in IDs for things like the VPC ID or the directory ID, is to give them the name of something, because that's more easily memorable, right? Let the script go and find out what it needs to run as a general principle, right, rather than use IDs. So the actual VPC peer name we're going to connect to is Underdesk Corp.
Okay.
And I think that was it for parameters. Again, we have verbose, but we're going to step through, so we'll ignore that. So let's start executing.
Okay, so again, testing our region, and then creating our CIDR from our base address, just adding that /16. And that's all you really need for creating the VPC, it's just that.
That's it.
And then tagging it. So we use that same resource group name. This VPC is going to be called reinvent, which looks like here you're doing some more dealing with the eventual consistency.
Yeah, it's eventual consistency, right? We need to make sure that the VPC is initialized before we start adding the subnets. It only takes a second or so, but just pause if this is running at full speed.
Okay. Then what are you doing over here, Steve? Getting
so what
fancy.
We're doing now is we're taking that base address, the 172.0.0.0, splitting it to its individual quads. Right? Then we're going to take the first two quads and we're going to increment the third quad. So 172.0.0.0, 172.0.1.0 with 24 net masks. Because we're going to create a subnet in every AZ. US West 2 has 3 AZs, so we're going to create 3 subnets.
All right. So we created our 3 subnets. And then it looks like you're going to filter all those to make sure they're all available. Is that right?
Yeah, so rather than poll each subnet to make sure it's available before we proceed, what I'm doing is making a filter that says give me all the available subnets in the VPC. When that matches the number that I created, I'm good to go, right?
Okay. And then
now this is the point. Yeah, sorry, you were going to say.
So yeah, here it looks like we would be creating our actual custom gateway, right? But it's not under here.
Yeah, so we don't have one, so we're going to simulate. So now we're going to set up the VPC peer to the VPC that we already have.
Okay, so we're going to go fetch that peering VPC, and we're going to actually request creating that connection there.
Right. So when you set up a VPC peering, the VPC you're peering to has to approve it. Someone or something has to approve that request. Right? Now, we could set up VPC peering with other accounts, right?
Right.
And we'd be reliant on them, whoever that is, to go and do the approval. Because we actually own these VPCs, we're going to do this from script. So we have to wait for the peering connection to reach a pending acceptance stage before we actually issue the command.
Okay.
And then we just run. So we just approve EC2 VPC peering connection. Right.
All right.
The two VPCs are now peered, but there's no traffic flowing between them. We need to configure the route tables now so that traffic can go from end to end. And that's all that these next two steps do.
Okay. So it looks like, yeah, we're setting up one route table. This is from our corporate network back to our new network, is that right?
I think so, yeah.
Okay, and then we're going to do the reverse, so we can have traffic going back and forth to our new networks.
Yeah.
Okay. Is that it?
That's it. We're done. Network's set up. Okay, let's go back to the slides. So Norm, what do you think about creating VPCs?
It was awesome. So yeah, with PowerShell, we learned how to actually construct, configure our VPC all with automation in PowerShell, learning the subnets, and also how to do all the peering, so we could have two different VPCs be able to communicate with each other. That was our simulation, since we don't actually have our corporate network. Yeah, that's it. Yeah.
All right. 2 of 4 done, nearly there. So the next stage is to launch our server. This is the easiest bit. We'll go straight back to the demo.
All right. So another breakpoint.
Yep.
Breakpoint.
Now this particular commandlet takes a lot more parameters because you have a lot more customization of how you launch an instance, but some of them are defaulted, so we'll go through that.
I had code monkey fail and forgot to say command. Okay. Okay, and so resource group new still is reinvent.
Mm-hmm.
Subnet zone. So
Right.
here we get to choose which.
So this script can launch multiple instances of the image in multiple subnets. Right? We're going to launch it one subnet, one instance. So in this case, you would type US West 2A, US West 2B, etc. as an array. Let's just use US West 2A or whichever one you fancy. Image ID we don't need, right? We're going to use that resource group name to go and find our image that we've imported. Right? We haven't actually checked up on the status of it, but I'm pretty sure it hasn't converted yet. So we've already got one to go. We're good. Instance type, if you don't specify it, this script defaults to a T2 small. Because we're launching in a VPC, we can use the T2s. Instance count will default to 1 if we don't specify it. And if you specify instance count, you'll get instance count instances per AZ that you specify. So if you give me 2 AZs, 3 instances, you're going to get 6 instances. Okay? Ingress IP and ingress port can be used to open up the security group. We're going to create a security group wrapping this instance, or the instance you're launching. And we can use this to control access into that instance at the security group level. Right? So let's specify the ports first.
Okay.
So what I want to do is I want to open up port 80, because we're going to use that for PowerShell remoting.
Okay.
Well, we're not going to use it. We're going to just set it up and show it. And then 3389. Because if you're sitting in your corporate LAN, you might want to remote desktop into this instance for some reason, or you might want to do PowerShell remoting. So we'll show you how to set that up. But we don't want everybody to hit this, right? We only want from our corporate LAN, which is on the 10.0 network, all right? So then we give an ingress IP of our 10.0.0.0.
Okay.
And then you need the /16. You could limit this if you wanted.
Okay.
All right, next one is managed policy name. So the policies that we saw earlier on are called inline policies. You saw the strings expanded. IAM also has the concept of managed policies. It has some defaults, and it has some that you can set up yourself. Right? In these ones, we just give it a name. If we don't specify managed policy name, the script will use power user access. So the script, the instances or code running on the instances can effectively call any AWS service. They can't do any IAM tinkering around. They can't set up users, etc., that sort of thing. So we can leave that one alone. PS remoting port that we want to use. Right? If you're behind a corporate firewall, sometimes PowerShell remoting is hard to set up. Right? What you need to do is pass a script across when you launch the instance. And this script will actually set one up for you for the port you specify. So we're going to use port 80 because that can get over corporate firewalls. This is what I used back in Seattle, two instances. We're good to go.
All right. All right, so again, check region and test VPC per line. We'll go in there. So here we're just trying to make sure we have our VPC.
So note, instead of passing in the VPC ID, we're going to go and find the VPC using the resource group name that we just gave it. Much more convenient for operators to use.
Okay, and then we need to go find the image that we actually want to launch, right? So you're going to go by that same tag name and do get image for that. Oh, I messed up, Steve. So I stepped over what we probably wanted to go into. It's down here, I believe. So we'll just look at that. So setting up the role, we would have set up, again, we would just set up another role with the assume policy. And then we're going to register the managed policy, which is the PowerShell, or the Power User policy, right?
Yeah.
Okay.
Yeah. So that's all we just did.
Yep.
Okay.
Okay. So we have that role. Now when we launch EC2 instances, we don't give roles. We actually have to give it an instance profile, right? So we need to wrap that profile, or that role, with an instance profile. So here we're going to go and create that instance profile. And then once we create it, we're going to add the role that we just created to that instance profile. All right. Now we're going to go create that security group we're talking about. So checking to see where it exists. I'm guessing it does not. So we are. Okay, we're just going to create just a security group. And then it looks like we're going to loop through all of our ports here.
Yep. So for each port that we specified, we're going to set up an IP permission object that has the IP address range that we want to restrict to it, to that open port. You can do it in other ways, but we're going to use IP range here. Once we have that collection of IP permissions, we just grant ingress. Right? We can also grant egress as well, similar command. Look. Pass back the group ID because we're going to want it on launch. Okay, so we're going to set up some basic launch parameters in our splat. Okay. So we requested that we want PowerShell remoting enabled on port 80. So when you set this up, what you have to do is set a small PowerShell script that configures WinRM on the instance on the port that you specify. And this has to be this has to be passed as a base 64 encoded string to EC2 on the launch. So this little helper function here you might find useful just this alone, okay? To build the PowerShell script that you need to configure with the requested port. Pass that back as the base 64 string, and then we just add it to our launch parameters. Okay. Now I said that we're going to launch in we could launch in multiple subnets. All this is doing is getting hold of my subnets for this VPC, matching them with the ones I specified on the command line, and then setting that as the subnet that we're going to launch into.
Okay. So then once we have that subnet, we do the launch command, and that gives us back our reservation.
Right.
Which that has its collection of instances. If we would have said more than one instance, it would have been more than it would have been that. But in our case, it's just that one. And now we're just going to go tag all those EC2 instances with that same tag we've been using throughout our talk today.
Yeah, note that we don't have to wait for them to be fully launched to tag them. We can do it straight away. Okay.
Okay.
And we just pass back the instances. That's it. Our server that we're currently converting is up, or their version of it is now up and running. In fact, why don't we go and check on the conversion progress?
Okay. Oh, there it is. Yeah. Let's bring that up. So we are converting.
Oh, it's converting, right? Okay, so
right.
back to the slides. So what do you think about launching?
So here we get to learn with PowerShell how we can actually set up our security groups and lock down access to our instances. And once we did that, we actually launched our instance into our VPC with our subnet for availability zone. We could have done it across multiple availability zones to give us that high tolerance. And then we learned how we could use the user data to actually run some PowerShell scripts in the initial launch of our EC2 instances. In our case, we use that to set up the PowerShell remoting.
We're nearly there. We have one more job to do, post-launch configuration. So Norm wants this server to be connected to the corporate network, corporate domain, and he wants to turn on CloudWatch monitoring. He wants the logs and collect logs and metrics from the instance so he can watch them securely online. Just make sure this instance is running just fine. And to do that, as I said, we're going to use Simple Systems Manager. Simple Systems Manager, or SSM, is a thin automation bootstrap layer for EC2 Windows instances. If you launch a public EC2 Windows instance, there's nothing on it. Well, it's technically not true. It has the EC2 config service running, it has the AWS SDK for .NET, and it has the tools for Windows PowerShell. But that's it, right? So you can use SSM to do things like auto-domain join. You can install PowerShell modules, you can install MSI packages, and you can set up CloudWatch monitoring and metrics. Now, if you're familiar with DSC, Chef Puppet, you're probably thinking, well, isn't this the same thing over again? Well, not really. It's actually complementary, right? Those instances that you're launching or could be launching, as I said, have nothing on them, right? So you need a way of bootstrapping that content, and then you can hand over, if you want, to do more detailed configuration setup afterwards. So think of this as a complementary tech to those systems. So what Norm has to do is basically create a configuration document, a JSON document. You then register that document with SSM, and then you ask SSM, hey, associate this with these running instances. You can check the status at any time with the commandlet, and optionally, you could configure those instances using Windows Task Scheduler to reapply that document on a scheduled basis. Okay? By default, the EC2 service on the instance will look every 15 minutes, I believe, for a new document to apply. You can force it to run using the CLI. So why don't we go and take a look at this configuration document?
All right, let's bring that up here.
So here we are. It's a very simple document. You can see we've got two what are called plugins, AWS Domain Join and AWS CloudWatch. These just contain a bunch of properties that configure the particular plugin. If we expand the domain join, you can see here that we've got some IP addresses for the DNS system in our directory, our simple AD, and the directory ID. If we expand the CloudWatch configuration, this is a little bit more involved because this is where we're configuring the event sources that we want, the log sources we want to capture and where they're going to go, and the metric sources and where they're going to go. Now, I am spectacularly inept at editing JSON documents. I always miss a comma somewhere or a colon or something.
That's
I can
true.
never get.
It does.
I can never get a valid JSON document from day one. So when I was setting this up, I was thinking, is there a better way of doing this? As far as I'm concerned, you may not agree. Obviously, this file, when you've got it in this document format, it's easy to put in a version control, right? It's one of the things about DevOps. We want to version control our configurations. But I started to think, well, this is just a hash table, right? Can I use a PowerShell hash table and have PowerShell do the heavy lifting of making me a valid JSON document that I can then use? I don't lose the configuration version aspect of it because I just version control my script. Fairly simple. So that's what I did. So let's go and take a look at the final function.
Okay, so another breakpoint. All right, I can't type all that. Too many people to watch for me to type that.
And this is the simplest of the scripts to launch. It just takes two parameters. First, the resource group name.
Okay.
We know what that is, okay? And then it wants the directory name. Remember that principle I said about don't make people type in IDs for things? Give them names they're going to remember. So we type in our directory name, which happens to be underdesk.corp.net. And then the script is going to go away and find out all that directory info it needs to configure that plugin.
Okay.
Enter.
All right. Oops. So testing our region again. And now let's go do our assume.
SSM, unsurprisingly, is going to want a role policy so it can do the work on your behalf, okay? That's all this is doing.
So we already have an IAM role on our machine. We're adding yet another policy on there is what we're doing.
Yeah.
And this is giving it all the permissions that SSM
So I'm
needs.
showing you this just in case you've set a more restrictive role policy on your launch.
In our case, that's not true since we set it as power user.
Yeah.
So we just write that policy to our existing IAM role. Okay.
So now we're going to build that runtime config that we just saw in JSON using hash tables, okay? So what we do is, again, we're going to go and get that directory using getDS directory, one of our AWS commandlets. We're going to break apart the directory name into organizational units. You probably have a slightly different OU thing, but this is what we need for today. And then we're just going to set up a hash table, the directory ID that we discovered, the domain name, etc., OU, and the DNS IP addresses. Nobody need to remember any of that, right? That gives us our domain join plugin.
Okay. Let me step in this. So This is what you're doing when you're creating these plugins. You're just using that to create that hash table.
Yeah.
Okay.
And we're going to do the same thing for the system event log, the application event log, event trace for Windows log. The logs all take a similar format.
Okay. And then the perf metrics.
In this case, we're going to capture just one metric for the memory.
Okay. And then what do you need the region here for, Steve?
So some of the plugins need the region information.
Okay.
So that's all that's capturing is what region am I running in, inject that into the hash table.
Okay.
So what we'll be building up now is just collections of hash tables. We're going to assemble those into another hash table, and so on and so on. Once we've got the metrics, the plugins done, we need to set the flows for CloudWatch, right? CloudWatch needs to know where do you want this data to go. I know where it's coming from, but where's it going to go? And it does that with flows. So you can set up a source to destination, a source to multiple destinations, or multiple sources to a single destination. So we want to send our logs, our 3 hash table logs, to CloudWatch logs, and obviously the perf metric to CloudWatch itself. And then we just assemble that runtime config that we saw in the file.
So that's where you're combining all those hash tables together.
Combining hash tables into another hash table, yeah.
Okay.
Pass that back. And now we can call our actual command that's going to do the work of associating those with the instances.
And so it looks like this. If I didn't want to use this hash table approach and I just wrote my JSON document, I could just call this command line, right?
Yes, yeah.
Okay. So we didn't have a file. We're going to convert that hash table.
So there's our master hash table now, the overall config. We're going to pass that through convert to JSON.
Okay.
Now we have a valid JSON document. No commas were harmed in the making of that script, right? So now we're going to register that document with SSM. Again, we're going to wait the SSM to say, yep, good, we can go. Again, it takes less than a second. Now we're going to go find our instances. Remember, we're going to use that resource group name now that we tagged the instance with earlier. Please go find me that instance.
Okay, they're all tagged.
We've done that, and then we're going to pipe the instances in for each one. We're going to associate the document. We could do that as a batch operation as well, but I decided to show it that way.
All right.
And that's it. Now, sometime within the next 15 minutes, and there are 30 minutes left, that instance will reach out, get that document, and start to apply, do the domain join, and do the CloudWatch setup. Right?
So once that's done, it will be on the join. I could go then also to our CloudWatch console and actually see some of the metrics there. Now,
if you wanted to take effect immediately, what you would do is now you PowerShell remote in to that instance. Remember, we configured PowerShell remoting. And you run the ec2 config-cli command with the -a switch, and that would cause it to go and reach out immediately and try and grab a document and apply it, if you need to do that. Right? That's it.
All right. So here I learned SSM, how we can actually use that to bootstrap our system, how to actually get it to join our domain. Didn't actually have to log in and do anything for that, just all done with automation. Steve showed us his fancy trick of avoiding JSON and using hash tables there. And we also were able to set up CloudWatch and CloudWatch logs, so we can be able to monitor this from without being on the machine. See what's going on.
That's it, we're done. We've gone from a server on a VM into the cloud in a private network. Now it's post-launch configuring and joining domains, etc., and setting up logging. So Norm, where do you think you might go from here?
Well, now that I actually have it in the cloud, I can start decommissioning the box that's under the desk. And I would really like to know what's actually on that machine. So one of the things now I have the benefit is I can actually go spin up test versions of this and play around with that and actually understand that while everyone else is using the first one. So this kind of gives me that easy way to test things out and without breaking everyone currently using things. I'd also actually like to start taking advantage of the multi-availability zones and make sure that we have this system always up and running on multiple zones.
Okay. So what we've learned then, in recap, how to use the tools for Windows PowerShell to automate how to get servers virtualized and imported into the cloud, constructing the virtual private network, and you might want to use that VPC peering approach to do testing, for example, if you're hacking around with network ACLs, etc. You might want to test them before you apply it to your corporate net. VPC peering is a good way of doing that with simulated VPCs for your corporate net. And how to configure those instances once they're running in a repeatable, consistent, and scalable manner. No button clicks, right? Got some links for you before we leave. The link to the where we put the samples. So yesterday's .NET session on core CLR and Docker, samples are in there, as well as the scripts that we just ran through today. Our AWS.NET blog, where Norma and the rest of the team back in Seattle do blogs on .NET and PowerShell development. There are 2 blog posts on there of interest, one from this year, one on the new import APIs that we saw today, and what was the second one? I've forgotten what the second one of interest was. Oh well, you'll find it. Just look for me on there, you'll find it. It's all PowerShell. And a link there to the managing the Windows instance configuration stuff from SSM. It's quite an interesting read. With that, I'd like to thank you for coming along. Hope you enjoyed it. Hope you found it useful. And please remember to complete your evaluations.